Hey everyone, and welcome. Let's talk about this little guy, the Moka Pot. You've probably got one sitting in your kitchen, right? It's an absolute classic for making strong, rich coffee at home, but the way it actually works, well, that's a whole different story, and it's probably not what you think.
So I've got a question for you. Do you think you really truly know what's going on inside this thing when it's on the stove? Because I'm willing to bet that the story you've heard isn't quite right.
You know the common wisdom, right? You put it on the stove, the water boils like crazy, and all that steam pressure just blasts the water up through the coffee. I mean, it makes sense. On the surface, seems pretty simple. Okay, but what if I told you that whole boiling water thing is basically a myth? Yeah, the real hero of the story is something completely invisible. So let's get into it and figure out what's really happening.
All right, first things first. To really get what's going on, we gotta know the parts. So let's meet the players and look at the anatomy of this brewer.
So when you take it apart, it's just so simple, isn't it? It's genius. You've just got these three main parts, and each one has a super important job. It's honestly a perfect piece of design. Okay, let's break it down. Down here, you've got the base, the water chamber. That's where the magic starts. Then, this bit, the filter funnel, is where you put your coffee grounds. And finally, the top part is the collection pot, where all that delicious coffee ends up. Simple as that. 3 pieces, one perfect system. All right, now for the really cool part. Let's talk about the actual science here, the hidden piston. This is where we uncover the real engine that drives this whole process.
So the big secret comes down to some really basic science, stuff you probably learned in middle school. Heat up air, and it expands. That's it. That simple idea is what powers your Moka Pot.
Check this out. When you fill the base with water, you never fill it all the way to the top, right? You always leave this little gap. Well, that gap is full of air, and that trapped pocket of air is everything. It's the secret weapon. Think of that pocket of air like a piston. As you heat the pot, that air gets hot, it expands, and it needs to go somewhere. So it starts pushing down on the water. It's this gentle, steady push that sends the water up through the coffee grounds. It's not a violent explosion of steam at all.
And get this is the part that blows most people's minds. The water starts its journey up at around 70 degrees Celsius. That's 158 Fahrenheit. That's not even close to boiling. And that's a good thing. If you used actual boiling water, you'd just scorch your coffee and get a really nasty, bitter taste.
This also explains why a Moka Pot doesn't make true espresso. You see, a Moka Pot gets up to maybe 1.5 bars of pressure. A real deal espresso machine, it's hitting you with around 9 bars of pressure. That's a whole other level, and it's why espresso is so intense and has that beautiful crema on top.
Okay, so let's talk about the grand finale. That famous gurgling sound. You know the one I'm talking about? The Strombolian roar.
No, I'm not kidding. Scientists actually call it the Strombolian Phase. It's named after the Stromboli volcano in Italy, which is famous for these little explosive bursts. How perfect is that for describing the sound of a Moka Pot?
So what's going on here? Well, by this point, most of the water is gone. The water level in the bottom chamber has dropped below the funnel. Suddenly, all that hot pressurized steam and air has a clear shot up the tube, and it violently forces the last dregs of water with it. And that is the gurgle.
And here is the most important takeaway, maybe of this whole thing. That gurgle is not the sound of your coffee being ready, it's the sound of your coffee being done. It's an alarm bell. If you let it keep gurgling, you're just shooting super hot steam through the grounds, which pulls out all this bitter, awful stuff. You don't want that.
All right, so we've got the science down. Now, how do we actually use this knowledge to make a better cup of coffee? Let's put this science to work.
The beautiful thing about understanding the science is that it gives you control over the final taste. And the number one thing you can control to make or break your brew, it's all about the grind size.
It's kind of like a Goldilocks situation. If your grind is too coarse, the water just rushes right through. You get a weak, sour, under-extracted coffee. Bleh. But if you go too fine, like an espresso grind, the water can't get through. It chokes the machine, gives you a super bitter coffee, and can even be a bit dangerous with the pressure buildup. You're looking for that sweet spot right in the middle, medium fine.
Okay, let's wrap this up. What are the big things to remember? Number 1, it's expanding air, not boiling water. That's the hero here. 2, the coffee starts brewing way below boiling, at around 70 degrees Celsius. 3, the gurgle means stop. Get it off the heat or you'll get bitter coffee. And 4, use a medium fine grind. That's your ticket to Flavor Town. So next time you're in the kitchen making your morning coffee, you'll know exactly what's happening. You'll hear that gentle hiss and know the air piston is at work. And you'll hear that final roar and know the volcano has erupted. So my question to you is, now that you're in on the secret, will you ever hear that gurgle the same way again?